Hi, this movie is for tangent lines. This is Learning Target 1 of the unit on circles. A tangent line to a circle is a line in the plane of the circle that intersects the circle in exactly one point. So you can see here, this line is intersecting this circle at point B. That's called a tangent line, where it intersects at one point. The point where the circle and the tangent line intersect we call the point of tangency. So we say that ray BA is a tangent ray and BA is a tangent segment. So we have tangent rays and segments. Please add this to your handbook. Theorem 12.1. If AB is tangent to circle O, then when we connect with a radius, we get a perpendicular line. So add that to your handbook. Perpendicular radius when it hits at the point of tangency. All right. Let's go to this problem. We've got a circle here, and we've got two radii. There's a radius and there's a radius. L and N are both tangent to the circle, so we know that this radius is hitting the point of tangency at a perpendicular. So we know those are both 90-degree angles. Now, we know that this whole part here is a quadrilateral. So we've got quadrilateral, and we know that the sum of the interior angles of a quadrilateral is 360. So I've already got two 90s. I have 90 plus 90 plus the 117. Then I can add the x, and that's going to be equal to 360. Now, if you forget, the sum of the interior angles is n minus 2 times 180. So if I had a five-sided figure, it'd be 5 minus 2 times 180. So that's how we got that it was 360. That allows us to set up our equation and solve for what x is. And you'll see that x is 63. B. Let's go to this one. ED is tangent to circle O. And what is the point x? Now, this is a radius, so it's hitting at a 90-degree angle. This is a radius, but this is not a tangent point, only D is. So x is up here, this is 38, so I know that 90 plus 38 plus x equals 180 since I form a triangle. That allows us to solve for x, and x is 52. All right, pause this movie, try this one on your own, and then press play when you are finished. All right, we've got a radius here and a radius here, so it's hitting our tangent line at the point of tangency at a 90-degree angle. So I know that I've got 90 plus the 152 plus x, and that is equal to 360. Now, how do I know it's 360? Because I have a quadrilateral DAGO, and quadrilateral angles add up to be 360. Solving that, we get that x is 28. All right, let's go to this one. Jasmine is riding in an airplane, so let's get an airplane. At an altitude, so with an altitude, let's look at, we've got the Earth, and we've got an altitude of 6.5 above the Earth, which means a perpendicular to the Earth. So that is 6.5 miles above the Earth. How far on the Earth can she see if the Earth's radius is about 4,000? So what we're asking is how far can she see here to the point of tangency out at the horizon? And we know that the Earth's radius, which will be this, is 4,000. Which means this is also 4,000. And we have that this is a right angle because we had a tangent line, and at the point of tangency, any radius will hit it at a 90-degree angle. Now that allows us to create this right triangle where I know this length is 4,006.5, and this length is 4,000. So I can use the Pythagorean theorem. And we'll solve for x. And then we just solve this. So we square it, we subtract, and we end up getting that x is approximately 228 miles. So this visual here, the x to the horizon, is about 228 miles. If a line is in a plane of a circle, it's perpendicular to the circle, then at that radius, we know that we're going to have a line that is tangent. So if we have this line hitting the circle at point P, and it hits the radius at a 90-degree angle, that's perpendicular, then it's a tangent line. So this is the converse of what we just saw. Add this to your handbook, pause the movie, add it, and then let's work on the next one. This one says, what is the radius of circle C? So the radius of circle C is x. You can see that here and here. Now we can see that because we've got a right triangle, we're going to use the Pythagorean theorem. The length of the hypotenuse is x plus 8. So we're going to strategically write this as x squared plus leg squared, which is 12 squared, equals the quantity x plus 8 squared. Now we're going to have to remember our algebra, because this gives me 12 squared plus 144 equal to, this is a binomial. This means x plus 8 times x plus 8. So we get x squared plus 144 equals, and we have to distribute this guy into both, as well as the 8. So we get x squared plus 8x plus 8x plus 64. So x squared equals 144, or x squared plus 144 equals, this gives me x squared plus 16x, I'm adding those two like terms, plus 64. Now I've got a quadratic, I'm going to subtract x squareds though, and now I don't have a quadratic. And I'm going to subtract 64 and then divide by 16. And we get that x is 5. So the radius of this circle is 5. All right, for the next one, I want you to pause the movie, try this one on your own, and press play when you are finished. All right, on this one, we've got that the hypotenuse is x plus 18. And so we've got x squared plus 24 squared equals the quantity x plus 18 squared. So we've got x squared plus, this is 576, equals, now if you simplify this guy out, you're going to get x squared plus 36x plus 324. Now the x squared ends up canceling. 576 equals 36x plus 324. And then we're going to solve this equation. Subtract 324, divide by 36, and we get x is 7. All right, let's look at this one. Is it tangent? Now, to figure out if this line MN is tangent to circle P, what we would have right here is a right angle if it was tangent. Now, the tricky thing on this is 13. Is 13 the whole length? 13 is representing this length of MP. Now, if that's a true statement, that length MP is 13. What we can do is use the converse of the Pythagorean theorem, where it says if a squared plus b squared equals c squared. So if 5 squared plus 12 squared equals 13 squared, then we know that we have a right triangle. And if we have the right triangle, then we know that the radius is perpendicular to line MN, therefore MN would be tangent. So we solve this and we see that we get a true statement. In fact, 5, 12, 13 is a Pythagorean triple. So we say that, it says to explain, so true, it is a right triangle. So MN is tangent to circle P. Okay, let's look at this one. This one always reminds me of a party hat. We've got two lines that are tangent to two different points, A and C in this case. So if two tangent segments to a circle share a common endpoint, where their endpoint is B, outside of the circle, then the two segments are going to be congruent. Just like in a party hat, you would have those two sides congruent. BA congruent to BC. Oh, add that to your handbook and then press play when you are finished. Okay. The sides of the triangle are tangent to the circle. So we know that the circle's hitting the triangle at these 3 points. We say that the circle is inscribed in the triangle. The triangle is circumscribed about the circle. These are terms that we're going to be using. That means that these two lengths are congruent, these two lengths are congruent, and these two lengths are congruent. Let's apply that. Circle S is inscribed in triangle LMN. What is the perimeter of LMN? So, we know that these are points of tangency here. If this is a length of 14, then this will be a length of 14. If this is a length of 8, then this will be a length of 8. And if this is a length of 5, then this is a length of 5. Now the perimeter is the distance around, so when we add all these together, 2 of the 8s plus 2 of the 14ths plus 2 of the 5s, we get that the perimeter is 54. And that's the end